Hello students, welcome to IMS Academy. My name is Gopal. In today's session, I am going to discuss number of problems on analog circuits. The subject is common for ECE, electrical and instrumentation students. The GATE exam is very close, 2.5 months till it is left. I hope it is now. At this particular moment, the students must practice more number of the problems. And each and every day, if the students are practicing 5 to 6 questions from each chapter, 100% it is beneficial only now. Today, around 15 questions I am going to discuss. And those 15 questions, when I show the slide, you start doing this question. If you are getting answer immediately, you try to message it now. I can compare with your answer only now. I am also going to do every one of the problem here now. All the 15 questions I am going to do here now. Understand now. It will be beneficial for the students. I hope it now. Understand now. Okay, I will start the session then. But problems we can do one by one here now. Understand. This is the first problem. Anybody can tackle this question without my help at first? Initially, I will give in the hands of the students. The students are in a position to give the answer very happy. If you don't get answer, no problem. I will give the clear concept of the problem and I will do the problem. Understand now? I will give some time. You please try to tackle this question now. I want to give you some time. You take some time and try to tackle this question now. Just to take 2 minutes and try to tackle this question. If you tackle, it is quite okay. Yes, one student is asking the question now. The high frequency analysis of BJT is not in the syllabus. That we have on the small signal analysis only now. Understand? And one more, BJT and MOSFET not present in the GATE. Understand now? That is very important now. 1.66 milliamperes. One student gave answer. I will check this answer. 1.66 milliamperes. Exactly correct. Very good, Ricky. May I know what is our branch? May I know, Ricky, what is your branch? I would like to know your branch also now. May I know that? May I know your branch? 1.66 milliamperes, perfect. One student gave answer. May I know your branch? Is it DC or electrical or IN? EC, excellent now. Yes, I will do the problem, please watch it now. But some students may think the sir is going somewhat slow because everybody must understand the concepts. That's why even if I go somewhat slow, no problem now. All the 15 questions I will complete in 3 hours, no problem, understand now. When a problem is given, you try to check it. Which diode is on and which diode is off here? Which diode is on and which diode is off? That is more important first. Then after we can find what is needed in the problem. What is given in the problem first of all? In the given circuit, the diodes are ideal. The current I through the diode D1 in milliamperes is asking to find the current across D1. Current across D1 is required. But both diodes are ideal. It is specified in the problem clearly. Diodes are ideal here given. What test is applicable to find the diode is on or off? Anybody can give answer? Which test is to be conducted to identify the diode is on or off? Anybody can give answer? Which test we need to apply? Anybody? Any student can respond for this? We need to identify, but to identify the diode which is on, we should apply short circuit method is one of the tests, and second one is nothing but the open circuit test. It is better to apply open circuit test. Short circuit test means there is one of the drawback. Suppose directly what now this diode is on, you tried and started to do the question and you are getting the I value. In case you are getting the I value any negative, you can say the diode is not working. If this current also you are getting means, suppose it is on, this current also negative you got, for example, this diode is also not on. First what now, both are on, we made an assumption. In case current I is a negative value, the diode is not on. That is one of the method, you know doubt. Open circuit test is very powerful and it is very simple only now. Understand now, that is better to apply. Okay, if you are convenient with the short circuit test, 100% you can apply. How to apply the open circuit test? Please watch it here now. Initially, I want to make an assumption both diodes are, but initially what I want to do, these two diodes are open circuited. In the open circuit test, you must remove the diodes like this now. Open circuit the diodes. There is a resistor 1 kilo ohm and supply voltage is given 10 volts. I will connect as it is. Diode D2 is here open in the open circuit test. D2 here. This is nothing but the anode potential, this potential. This potential is nothing but the cathode potential, you know very well. And the resistor is given 1 kilo ohm. I will connect as it is 1 kilo ohm. The 1 kilo ohm resistor I want to connect here as it is. This diode also open circuited. In the open circuit test, we are going to identify the diode is on or off. This is anode, this is a cathode. This potential, I want to take it as an anode potential. This potential is nothing but the cathode potential I have taken here now. This source is given 3 volts. And 1K resistor is connected this side. I will connect this also. This is 1K. Just open all the diodes at first. When you will say the diode is on, everybody knows very well. When anode potential is greater than cathode potential, diode is on for ideal case. For ideal case, I say. If the diode is given non-ideal, you think it's so. VA minus VC must be greater than or equal to 0.7 voltage must. If it is non-ideal diode. So here the ideal diode, it is specified clearly. At the time VA is greater than VC or not, you need to check. If VA is a less than VC, you think it's so diode is off. If VA is a greater than VC, diode is on. Based upon that concept, we can tackle only now. What is this VA? This voltage is nothing but this node voltage itself. In this case, the circuit is connected with 10 voltage. Is it passing any current through this wire or not? 100% it passes across 1K and 1K. But there is some drop across 1K and 1K. But these two resistors are same. At the time, voltage across this 1K is to be taken as a 5 voltage. Here 5 voltage drop, here 5 voltage drop possible. I can write here clearly, this voltage is nothing but 5 voltage I can put here now. If it is 5 voltage, VA is nothing but same 5 voltage only now. Same 5 voltage we can give for this anode potential. What about the cathode potential? The cathode is connected to the what? Ground directly. This is now. I cannot take this side, it is a open. I can go this side, it is a 0 potential we got if it is a grounded now. So VC is to be taken as a 0 voltage only now. Now please check it. Anode voltage is greater than cathode voltage or not? Please check it. 100% greater than only now. If VA is a greater than VC, diode D2 is on state. We got the concept. The diode is on. In ideal case, if the diode is on, we can short circuit later on to find out the what required current. I want to check second diode. But in this case, VA is nothing but the same 3 voltage I will get. Same 3 voltage. May I know what is the VC value here? May I know the value of VC here? Anybody? The VC is nothing but the same 0 voltage I will get here now. Same 0 voltage. Even in this case, VA is greater than VC value. If VA is greater than VC, 100% diode D1 is on. I can say D1 is on here now. D1 also on here now. Yes, we got the concept. Both diodes are on here. If both diodes are on, we need to find out the current I. I can redraw the circuit and I can find out the required current I. I will draw in the what now? Next page best. But I am drawing the circuit here now. Here given resistor. This voltage is nothing but the 10 voltage. Here connected with 1K. Here connected with 1K. No doubt. Both are connected with 1K. And also what is given here now? This diode must be, this diode is on. Here we got. D2 is on means it must be replaced by short circuit. 1 kilo ohm resistor we have here now. This is with 1K resistor. And also this diode also on. D1 is also on. That is connected with what voltage? 3 volts here connected. Connected with 3 volts. And the resistor is 1K. In this problem is asking to find this current I. This current is required. You know very well. This current is I. This current is nothing but I1 I have taken. The I1 plus I is nothing but the I plus I1 equal to I have taken as a I2 I have taken for example here now. So I want to say here now I plus I1 equal to I2 you know very well. I plus I1 equal to I2. I want I. What is I? I equal to I can write I2 minus I1 only. I2 minus I1 is nothing but I is possible. But how to get I2 and how to get I1 is more important. Directly you can get it is not a tough task. What is I2? I2 is nothing but this potential equal to how much here? This voltage by resistance. This voltage same voltage only 3 voltage only now. 3 by 1K is nothing but I2. 3 by 1K. 3 by 1K I can put. What about I1? If you want to find out the I1, this potential is more important. Without knowing this potential, I cannot apply Ohm's law here now to find out the I1. How to get that voltage? We should apply voltage division formula. How to apply a voltage division formula? This voltage is nothing but the V for example. This is V. But how we can apply the voltage division formula? This current plus, well, not voltage division. Voltage division not applicable. Current this side and this side and this side you got now. 100% it is applicable. Nodal analysis only now. Nodal means this node you select, the direction of the currents to take away from the node. Away from the node we can connect. The V if you want to find, without knowing the V, I cannot find current I1. So nodal I want to apply V minus 10 V minus 10 divided by 1K. Summation of all the currents equal to 0, you know very well. This current is V by 1K. And this current is nothing but V minus 3 divided by 1K. I can write here now. That equal to 0. The 1K will be cancelled. V plus V plus V. 3V equal to, I can get 13. I want V value. But I will get V value as 4.33 volts possible. 4.33 volts possible. That much value possible V. Now we can get easily now. What is I1 here now? V minus 3 by 1K. V means 4.33 minus 3 divided by 1K. And finally, the value of current I is, 1.666 repeating. 1.666 it is repeating. Finally, we can write 1.67 approximately. 1.67 milliamperes of current is possible. That much milliamperes of current is possible. That much milliamperes of the current. I hope you followed. Did you understand this question? Any students are having any doubt? If there is any doubt, you can ask. Shall I go to the next question? Shall I go to the next question? Ricky, shall I go to the next question? Are you ready? Yes, I want to give one more question now. This is the next problem. But I want to give you time here now, just 2 minutes, just enough I think now. Just within 2 minutes you can complete this question. Yes, anybody is getting answer? Anybody is getting answer for this question? If you are getting answer, you can give. Expecting your answer. This session is for the beneficial of the students. That is why the students must practice this question. They must do. They must give answer. Even they have done same problem at their home, once again they can try. The revision also will be complete here now. Follow my point? Any student getting answer for this question? If you don't get answer, I will explain now. Okay, anyhow, I will explain, no problem now. Understand now. Anybody? Yes, I will explain. What is this network? Can you name this network? Can you name this network? What is the name of this network, I say? What is the name of this network? Anybody has got idea? This is the question from the rectifiers you know very well. And watching the circuits you can identify. It is from the rectifier only now. But is it from the half wave rectifier or full wave rectifier, you identify. There is a transformer, 2 diodes connected, load is connected, AC supply is given, 100%, it is a full wave rectifier. And also it is a center tapped rectifier only now. But here in the what is given problem, you check at first, and what is asking in this network, you can identify. In the circuit shown, the N:1 step down transformer and the diodes are ideal. Diodes are ideal. The diodes have no voltage drop in forward bias condition if input voltage in volts is Vs of t equal to 10 sin omega t, and average value of load voltage VL of t in volts is 2.5 by pi. The value of N is asking to find this N value. N:1 turns are given here now. But in the full wave rectifier and also in the step, in the center tap, you know very well, practically it is used step down transformer only. We are not going to use step up. Generally, this is the input you will get from the what? Some source. Some source you are going to get, that is a high voltage only mostly possible. The diodes are in need of low voltage only now. The directly that high voltage if you are giving means the diode will, what happen now, will damage only now. That is why we need to use the 4. Is it 4? Exactly correct. Nice, Ricky. You are getting answer. Answer is 4. Very perfect. Option A is correct. 100% perfect. Okay, option A is correct here now. But here the step down transformer is used to reduce the what now? Output secondary voltage only now, because diodes are in need of low voltage only now. How we can find the N value here? You know very well. The voltage across, so input voltage 10 sin omega t is given, source voltage is given Vs equal to 10 sin omega t is given in the problem. That much value is given here now. Is it correct? And also here, average voltage is given, average value of the load voltage VL of t is given 2.5 by pi. Average voltage means this voltage across the load. I say average value of load, average value of load voltage, average value of the load voltage and VDC both are same only. That is nothing but for full wave rectifier, what is average value of the load voltage? Anybody? 2 Vm by pi, everybody knows. 2 Vm by pi is the average value of the load voltage. VDC 2 Vm by pi. But the average value of the load voltage is also given 2.5 by pi is given here now. This is equal to 2.5 by pi. That equal to 2.5 by pi. Am I correct? Average value of the load voltage, you know, 2 Vm by pi for the full wave rectifier. But that average value of the voltage is given 2.5 by pi. That also taken here now. Now here the maximum voltage, if you know, I can find the value of N. How to find the Vm value? The turns ratio N:1 given. For transformer, voltage and turns relation, you know, V2 by V1 equal to N2 by N1 only. V2 by V1 means V2 means this is a Vm value, this is a Vm value. Here Vm is possible, here the Vm is possible. 2 Vm I will get V2 value. 2 Vm by voltage and turns relationship. From the transformer I selected V2 by V1 equal to N2 by N1. V2 is nothing but Vm plus Vm 2 Vm by V1 input voltage. How much? V1 10. That equal to N2 by N1, 1 by N, I can get here now, 1 by N I can get, V2 by V1 equal to N2 by N1. From this I can get what is Vm. Vm equal to 2, 5 times cancel, 5 by N I can get here now. phi by n I can get. This Vm I can substitute here now. Pi cancel here now. 2 into, I want to substitute this now. Here. 2 into Vm. What is Vm here? Phi by n. Pi cancel, that equal to 2.5. That equal to 2.5. My aim is to find n. N equal to 10 by 2.5. 10 by 2.5. Finally, how much 10 by 2.5? 10 by 2.5 is nothing but 4 only possibles. N equal to 4. So, which option is correct here now? Option A is correct here now. I say here option A is correct. This option is perfect in this particular problem. I hope you followed. Like that we can tackle. Followed? Any students having any doubt? Any students having any doubt? If you have any doubt, you can ask immediately now. Just applied V2 by V1 equal to N2 by N1. By using that, we got the what now? Maximum voltage. That maximum voltage is substituted here now. Then I am getting the what now? N value. That is one more good question. And I want to give one more question. You please try this. I will give you time. By using the diodes, all these problems are given. By using the diodes only now. I want to give 2 minutes for this question. It doesn't take more than 2 minutes. You please tackle this question. Yes, please try this question. Yes, time up. Any student getting answer? Nobody may say solution for this question. If I get answer from your side, it is very happy. May know. This session is particularly for the particularly for what now? Practicing only now. You need to practice more. This session must be helpful to the students. And once they were doing these questions before my answer, it is an excellent. That work only required in this GATE score booster. That is going to help you to improve your level. Understand now. But I may know the magnitude. What is asking the problem? Let me check it this now. Question what is given. Assume that the diode in the figure has V on equal to 0.7 voltage, but is otherwise ideal. The magnitude of the current I2 in milliamperes is equal to dash. Is asking to find the current I2 here now. This current is required. current I2 is required. Nobody is getting answer. Anybody is trying or not? Let me know. Let me know who are the students are trying this question. Ricky, not getting answer. Have you tried or not? Let me know. Yes, I will do. Please watch. I will do now. Students should understand. Don't think I am going slow, because every student must understand. Even the students are somewhat weak in the subjects, they must understand. That's why I am going somewhat slow. Understand my point now. And in this problem, the diode is in the figure has V on equal to 0.7 voltage. Voltage across the diode is given 0.7 voltage. 0.7 voltage drop only possible here now. Otherwise, it is an ideal. It is given. Yes, somebody gave 0. Ricky gave 0.56. 0.56 is not right, Ricky. Ricky, it is not correct. Okay, no problem. I will do here now. But the first initially, what is the name of the network? We don't have an idea. One network is given with a diode. One network is given with a diode only. But one network, it is not a general network. It is not a clipping circuit. It is not a clamping circuit. It is not a rectifier. In that case, we should identify the diode is on or off. Once you know the diode is on or off, you can come to the conclusion and you will know the method to tackle the question only now. We can check at first the diode is on or off. But to check that, what method I said now, open circuit method is a powerful tool to find out the what now? The diode is on or off. How to identify the diode is on or off? Initially, we should assume we should what now? Open circuit this diode only now. Initially, we have to open circuit the diode to identify whether it is a on or off. I say this network is drawn like this with open circuit. Diode is a open circuited here now. I connected with 2 kilo ohm resistor here. It doesn't take really more time. 1 minute is just enough to get there. Yes, somebody gave. Naveen Kumar, 0.217 milliamperes is also not correct. That is also not correct. Mistake is there now. I'll do now. Please watch. But this potential, I can say it as a VA here. This is the cathode voltage. This is the anode voltage. This is the cathode voltage VA and VC. Here connected with 2 kilo ohms, no doubt. Here supply voltage is given with 2 volts. This is with 2 voltage, you know very well. And 6 kilo ohm resistor is connected here. 6 kilo ohm resistor is connected. You please tell me, without my help, the diode is on or off. Your conclusion? What is your conclusion? You identify the diode is on or off. VA is greater than VC. VA, here the diode is what? Internal drop of the diode is given 0.7 voltage. VA minus VC is a greater than or equal to 0.7. It is a on. Otherwise, it is a off only. What do you say? Is it on or off? The diode is on or off. Please respond. Your answer is required. Diode is on or off here. Anybody can give answer? Diode is on, Ricky says. We can check it now. What is anode voltage here? This anode voltage, same 2 voltage you can have. VA is nothing but the 2 voltage I have. The cathode voltage is nothing but this voltage is the cathode voltage, same VC. This voltage, because it's a closed circuit. This voltage is nothing but voltage across 6K is nothing but the VC value only. Am I correct? But what is this voltage? This voltage means this minus voltage across 6K, voltage division formula I can apply to find the VC. I say VC is nothing but 2 into 6 by 6 plus 2, 8. 2 4s we can cancel, 2 3s, and also what I can write is 2 3s and 2 4s. I can write directly now. 2 into voltage division formula, 2 into 6 by 2 plus 6, 8. 2 4, 6 by 3 by 2 here, sorry. 3 by 2 we can write here now. But if it is a 3 by 2, I can get 1.5 volts I am getting here now. Vc is nothing but 1.5 voltage. Even this voltage or this voltage same only. Now you check it here now. Please try to check here now. Va minus Vc, we are getting 0.5 exactly. Abhishek, you are perfect. The diode is off. I said it is a diode is a non-ideal diode. 0.7 voltage is given. At the time Va minus Vc 2 minus 1.5, 0.5 voltage only possible. 0.5 voltage means this diode is not on. This diode is a off state only possible. The potential required to make that diode on 0.7 voltage is required, but we don't have that much voltage here now. At the time the diode is off, we can say Va minus Vc is 0.5, it is a less than 0.7 voltage you got. So diode is off. Diode is off. 100% diode is off. If diode is off, you can find what is asking current across. This is asking to find. So this assumption is correct. Diode is off only. The open circuit diode is off only. Then this current I want I2. So the same current I2 is going to flow this side. Otherwise you can say 1.5 by 6, no problem. 1.5 by 6 you can put directly. Understand? Otherwise this total current I2 equal to, otherwise you can say I2 equal to voltage by total resistance. 2 by 2 plus 6, 8K. 0.25 milliamperes of current is possible. 2 by total resistance. Otherwise, this node voltage by 6K. Acceptable. Any sort of way you can tackle. Finally, answer is 2.5 milliamperes possible. I can put here now. 2.5 milliamperes. 2.5 is the answer. That is the answer. I hope you followed. Followed others? Followed or not? Please tell me. But Abhishek exactly gave the here now. The diode is on. That point is very important because the difference of the voltage 0.5. Very perfect. And I want to give one more question in your hand. You please try this. First I am doing the problems based upon the diode circuits. Then after BJT, then after feedback amplifiers. Today we can discuss these three topics only now. In the tomorrow also we have the session. There I will discuss operational amplifier and MOSFET. These two are very, very important gate point of view. That's why you need to pay more attention. More number of the problems are required based upon the op amp and MOSFET. You will see and stand now. These are also more important. Next question. Yes, you please try this question without my help. I hope everybody will do this question, I think. Can you complete this question without my help? I will wait for some time. Please write. It doesn't require more time. Just 1 minute is just enough to complete this question. 1 minute is just enough. It's not required more than that. 1 minute is just enough. Please try this. Yes, time up. Nobody responded? May I know what is answer for this question? You are not given any options. Yes, the Ricky gave how much? 0. 0 voltage is 100% perfect. The voltage is a 0 voltage. Very simple question, this one. Very, very simple problem. But in this case, you can understand clearly. If you are, but the diode D1 and D2 in the figure are ideal. These two are ideal diodes only. And the capacitors are identical. These two capacitors are identical. The product RC is very large compared to the time period of the AC voltage. As compared to the time period of the RC is a far more greater than capital T is given here now. Assume that the diodes do not break down in the reverse bias. No breakdown possible in the reverse bias. The output voltage V0 in volts at the steady state is V0 value required. V0 is required in the problem. How we can tackle this now? But here this is nothing but the sinusoidal waveform. 10 sin omega t is the sinusoidal waveform. During positive pulse, you need to identify which diode is on and which diode is off. And during the negative pulse, which diode is on and which diode is off, you take it now. If the diode is on, it is going to charge the capacitor. The diode is off, no charging of the capacitor is done. The charging of the capacitor entirely depends upon the conduction of the capacitor only now. Conduction of the diode only here now. There's a diode is conducting, then capacitor will be charged only, we can say. In the problem, it is clearly given diodes are ideal, no doubt. But I wish to take during positive pulse, I wish to take here now during positive pulse what is going to happen. Systematically we can do now. During positive pulse, I am giving the, because it is a sinusoidal waveform only now. During positive pulse. During positive pulse, the peak voltage of that pulse is nothing but the 10 sin omega, 10 only now. 10 is the what now peak value only, you can say. During the positive pulse, this is a D1, this is a D2. D1 is on or D2 is on or both are on or both are off. Anybody can say? Which diode is on during the positive pulse? Anybody can respond? Any student can respond which diode is on here? I want to know which diode is on here. Any student? Any student can respond which diode is on in this particular circuit? Abhishek, Rikhi, can you give answer? Yes, both are on, very good, excellent, because the 10, this side 10 voltage, this side 10 voltage, both diodes are on. If both diodes are on, what is going to happen? It is a short circuited now. During positive pulse, D1, D2 on. Then they must be short circuited here now. If it is short circuited, how the voltage will be developed across the capacitor? I am giving the positive pulse here now. This is the voltage given here now. This is the input voltage VA I have taken for example. And this diode also shorted here now. Both diodes are on. 10 voltage will go positive pulse plus minus polarity. This positive pulse will going this side, this positive pulse is going this side, sorry, same positive pulse, I say. Both are positive pulse this side. And here I can put this also same positive. And finally, this is plus, this is minus. This is with 10 voltage. This pulse amplitude 10 volts. This pulse amplitude is a 10 voltage only possible. There is a resistor R. This is V0. This is V0, everybody knows. But during the negative pulse, what is going to happen? If I give during negative pulse, when the negative is given to the p-type semiconductor, negative is given to the p-type semiconductor, both diodes are on. Both are open circuited only now. No more charging is done. I said during negative pulse, D1 equal to D2 equal to half only possible. Then finally, V0 voltage across R equal to what? Same voltage, this voltage only. Apply KVL from top to bottom. I can take V0 is nothing but, when I go this at plus 10, when I go down minus 10 volts, finally it becomes a 0 voltage only. Answer is 0 voltage only possible. Just apply the KVL from top to bottom. 10 minus 10 becomes a 0 voltage only. I hope you followed. But I hope you followed this question. Please note down this. Please note down this. Yes, one more student is asking. Sir, what happens if non-ideal diodes are present in the circuit? Very good, excellent question. Non-ideal diodes are connected here, you think it's so. The same what now 10 voltage will not be developed here now. The 10 minus some drop is possible. 10 minus 0.7 you can get the rest of voltage only. 10 minus 0.7. How much? 9.3 voltage will be developing. 9 point plus 9 by 9.3 minus 9.3 only possible here now. Understand my point? 9.3 is available. Followed my point? If it is a non-ideal diode, 0.7 you have to subtract from the what now? 10 voltage only now. Rest of voltage will be developed across the capacitor. Did you understand, Ricky? Did you understand or not? Please tell me. Followed or not followed, Ricky? Followed or not followed? If it is a non-ideal diode, there is a drop. The drop you know very well. So supply minus the drop. Rest of voltage will be developing. Yes, I will give next question. This is the next question. Please try this question without my help. Please try this question without my help. I will give you time. It doesn't require more time. Just 1 minute is just enough. 1 minute is just enough to tackle this question. Please try it. Yes, time up. Any student has done this question? It doesn't require more time. Just 30 seconds are just enough to give the answer. Anybody has done this question? Are you getting answer for this question? May I know it? Any student getting answer for this question? If you don't get idea, you ask me. I will do systematically. Directly you do, sir, we can do this question. Systematically I want, sir, systematically also we can complete, no doubt. Your wish. Please tell me. Getting anybody? Yes, I will do now, please watch. What is given problem? In the circuit shown, assume that diodes D1 and D2 are ideal. In the steady state condition, the average voltage VAB, this voltage in volts across 0.5 microfarads capacitor is dash. Is asking voltage VAB only. Voltage across this capacitor is required. Anybody can say, what is the name of this network? Is it just one diode circuits? It is unknown, sir. Means okay. So it is a known circuit, sir, means okay. You tell me which is right. Is it a known circuit or unknown circuit it is? Just by watching the circuit, you can come to the conclusion. But you know very well, is it a clamping circuit or rectifier? Is it a clipping circuit? You need to check. Then we have to do the problem only. But in this problem, this circuit is a clamping circuit. Directly you can say capacitor, diode, and also capacitor and diode here given. Diode and capacitor given now. This is the given circuit only now. This is the circuit here now. This is the clamping circuits. But I will redraw if you want, you will get the clear idea. If you want to get the clear idea, I can draw. I can draw in this way. There is a source 50 sin omega t. 50 sin omega t. 50 sine omega t here given. 1 microfarad capacitor is given here. And here connected between these 2 points, here connected one diode. I will connect the diode directly. This is diode D1, I can put here now. But after diode, from this point it is connected diode D2. I can connect this diode. This is D2. But after D2, here connected with a capacitor. This capacitor is directly connected to this p-type semiconductor. Yes, this side connected. This is 0.5 microfarads. 0.5 microfarads it is given. The polarity here given, this point is A, here given clearly. This point is a B. And here given this with polarity plus and minus. Here given VAB, this voltage. Is asking to find VAB here now. This is VAB. But how to find this VAB? Anybody get? The diodes are given ideal, no doubts. But here, you know very well in the clamping circuit, one condition is there now. First, conditionally, directly, by applying the simple formula, I will explain. Not followed, sir. I don't want direct formula. You do means I will do, no problem. But in a clamping circuit, initial capacitor can have a voltage of Vmax. The first one will have a voltage of Vm. The second capacitor will have voltage of, this voltage will be 2 Vm is possible. In the clamping circuit, first one with Vm, second one with 2 Vm, third one 2 Vm, fourth one also with 2 Vm, the rest of capacitors with 2 Vm only. The starting capacitor with a Vm only. The next capacitor is with 2 Vm only now. Sir, why in the third capacitor it will not develop 3 Vm or 4 Vm, sir? The reason is the diode is not a amplifier here now. The diode will not amplify the input voltage only. The diode, the transistor means it can amplify. But input voltage we are giving peak to peak how much here? Minus Vm to plus Vm we are giving this sinusoidal waveform. Minus Vm to plus Vm only possible. The difference of the voltage Vm minus Vm is nothing but the 2 Vm. The voltage across the capacitor will not cross 2 Vm value. It won't be crossed. If it is crossing the 2 Vm, you think it's so. You can say directly there is no necessity to develop the transistor directly now. This is acting as an amplifier only, you can say diode now. But it is not acting as an amplifier. It can develop the input voltage, whatever you gave it, that much only possible here now. If it is an ideal case only now. Anyhow, we are going to get here now 2 Vm. I can get VAB equal to 2 Vm only from clamping circuit, this condition. 2 into Vm, what is the maximum voltage here now? 50 voltage only possible. 50 plus 2, here I am getting the 100 volts, it is available. The value is 100 volts possible here now. We can write clearly. Here I can give clearly. The voltage developed across this VAB is nothing but the 100 volts here possible. That much voltage is possible, so 100 volts only possible. Followed or not followed? Any students? If you are not satisfied with this answer, I can do conventionally. Just 3 or 4 steps I must do to give the answer. Are you satisfied or required other way also? Please respond. Is it required any other way or not required? Anybody? This method is quite okay. Is it required any other method? Second method also required otherwise? If not required, I can go to next question. Nobody is responding? Anybody is in need of the second method or not required? If you followed, I can go to next method. Next problem I say. Yes, okay. This method followed I think now. Vm, 2 Vm possible. Mostly we are getting 2 Vm from the clamping circuits. Understand now. But if the students are willing to do by the one more method means, so you can explain then now. Just I will give the idea, you can try. When this diode will be on, initially this diode, You need to give input of negative pulse only. The first diode must be forward bias, means you must give with what? Negative pulse only. If you are giving the negative pulse, what is going to happen now? This diode is on. This is a forward bias. This is a minus plus negative pulse. This is on. Then it can develop here now minus, and this polarity you will get. This is a plus minus will be possible. But this diode will be off state. Negative pulse you are giving minus. Minus means this diode is off. This is an open circuit only. Then developing VM only. In case you are giving the positive pulse, you think it's so. This diode is off. This diode will be on. The time what is going to happen? This diode is off means this is an open circuit. This is a short circuited. VAB required. Just apply the KVL. You will get the what now? Same 100 volts only now. Like that also you can do. No sir, very simple way I want to do the now. VM to VM. Even third capacitor to VM, fourth capacitor to VM. Finally, VAB is nothing but the 2 VM, 2 into 50 here, 50, 100 volts we are getting. I hope you followed. I want to give one more question in your hand. Please try this. Next problem. With the same diode concept, I want to give one more because certain push questions required, because the diode, some students are going to face problem with the diode only. That's why I gave it now. Clipping and clamping and also simple circuits I gave it now. Understand now. Now for the clipping circuit, I will give one question. Please try. Please try this one. Diode with Zener diode is given. You take 2 minutes. Yes, time up. Getting anybody? Any student getting answer for this question? You can message if you get answer. You can message if you get answer. Anybody? Any student is getting solution for this question or not? Let me know. Let me know. Nobody is saying there now? Yes, here it is given. The diodes are given. How many diodes? 2 diodes are given. 1 Zener diode is given. What is asking in the problem? Please check it. In the following limiter circuit, it is a limiter circuits, just like a clipping only now. In the clipping process, they will use the diodes and also Zener diodes also. In the following limiter circuit, an input voltage Vi is a 10 sin 100 pi t is applied. Assume that the diode drop is 0.7 voltage. When it is forward bias, the G0 breakdown voltage is 6.8 voltage here given. That means these diodes are not ideal diodes. Clarity we have. If it is forward bias, the voltage drop across the diodes is 0.7 voltage is given. The breakdown voltage of the G0 diode is given 6.8 voltage only now. Now you need to identify, but in the problem what is asking? The maximum and minimum values of the output voltage respectively are. I want output voltage, that is V max and V minimum required here now. Why do you get V max and V minimum? When you are giving positive pulse as an input to the circuit, you are going to receive V max. If you are giving the input voltage of negative pulse, you think it's so, you are going to get the V max there in the first case. Second case, V minimum is available. During the positive pulse, output voltage of V max you will get. During the negative pulse, you are going to get V naught output voltage of V minimum only now. We can see how the output is available, how the conduction of the diode is done. But here during the positive pulse, input voltage Vi 10 sin 100 pi t given. I am giving initially positive pulse. During positive pulse, what happens? During positive pulse, during positive pulse means I am giving 10 maximum voltage here now. I am giving 10 voltage here now. This is 1K. Now you please tell me diode, okay, we can connect another. D1 is on or off here during the positive pulse. Positive is given to P-type semiconductor. This is on, D1 is on. The positive pulse is given to the N-type semiconductor, N-type material in the PN junction now, N-type material. Diode D2 is off. I can say during the positive pulse, D1 is on and D2 is off only possible. But in the G0, this is the P-type semiconductor, you know, this is the N-type semiconductor, N is given to positive. This is a reverse bias only. Reverse bias means breakdown voltage only possible. Everybody knows very well. This is a 1K, here the diode is connected, but this is a P-type and N-type positive. Diode is replaced by voltage source. Its forward voltage drop is 0.7 voltage. If it is on 0.7, this voltage is given here now 6.8. We can connect here now. This is the negative polarity we are having here now. This voltage 6.8 voltage only possible. This diode is off, you know very well. But I want V max. I want to get V max. This voltage I want here now. This input voltage we are giving 10 voltage plus minus. This is given with 10 voltage. Anybody can give what its value? What its value possible? How much voltage we can get here now? But whenever the KVL is applied this side, you will get the V max. V max you can get. How much voltage you will get? Please tell me. What is the value possible? If I apply the KVL, when I go this side, plus 0.7 V max. 0.7 voltage. What polarity I will get here now? Positive pulse is given. Positive means this is with a plus only possible. This is a minus. That means a P and N type is given to positive pulse only. N type is given positive. That is why positive only. Plus 0.7 plus 6.8. 7.5 voltage here possible. 7.5 voltage is possible. That is the V max. That is the V max I can get. But I want to find what is V minimum also. V minimum also required from this question. How to get V minimum here? V minimum means during negative pulse what is going to happen, you please check it. During positive, negative pulse, when the negative pulse is given here, this is 1K resistor here. I am giving here the negative pulse only now. Minus here 10 voltage, this is a plus possible, negative minus 10 I am giving here now. And this diode is a on or off. The p-type material is connected to the negative pulse. This diode is off, reverse bias. If it is reverse bias, this is open. This total branch can be removed. All the elements you can remove. Anyhow, it is an open circuit. This is open circuit. This is open circuit. And what about this diode? This is a p-type semiconductor. It is an n-type. N is given negative only. N is given negative polarity of the pulse means diode D2 is on. If it is on, I can connect with minus and plus. This is a p-type. It is an n-type semiconductor. N means negative and positive. Minus and plus. Voltage across this, how much? 0.7 voltage only. The voltage across these two terminals must be taken as a V minimum only. This is V minimum. This is V minimum. From top to bottom you go. What is V minimum? You will get directly. V minimum equal to how much? When I go from top to bottom, minus 0.7 voltage I am going to get. The finally V maximum is 7.5 voltage. V minimum is nothing but the minus 0.7 voltage. Which option is correct here now? The option B is correct, I can say. Option B is correct in this particular problem. Option B is correct in this particular problem. This option is correct. Please note down this. You can note down. That is the solution for this question. Followed. If any student having any doubts, sure they can ask question. They got a right to ask questions. Yes, I want to give one more question in your hand. Please write. I want to give you one more question. Yes, you please tackle this question. I will give. Next problem. It is also diode question. I'll do diode questions, BJT and small signal, DC and AC analysis both I will do, and also feedback amplifiers I will touch instead. Yes, I want to give 2 minutes for this question. It is a question from the clipping circuit. Please tackle this from the clipping. We are doing the questions from the clipping, clamping and rectifiers. Yes, you please try this question. Yes, time up then. Anybody getting answer? Any student getting answer for this question? Nobody messaged any solution for this question. Do you have idea about this question or not? Please check it. Do you have any idea about this question or not? Yes, how we can tackle this question? You please watch, I will explain. What is given problem? A voltage signal 10 sin omega t is applied to the circuit with ideal diodes. Yes, the diodes which are connected in the circuit are ideal. It is a gate question, 2003 2 marks question. Applied to the circuit with ideal diodes as shown in the figure. The maximum and minimum values of output waveform V out of the circuit are respectively. Is asking the V max output V out required. V out is required. There is a V max and V minimum. Just like the last problem, he is asking to find the V maximum and V minimum. But what way we can do? Initially, you need to assume here during the positive pulse which diode is on and which diode is off, you identify. The diode is a forward bias or reverse bias for the starting pulse, you check it. And for the negative pulse also you identify which diode is on, then you can find output voltage very easily now. But if you want to get the V out, V max, you need to take, I say, during the positive pulse, you must do like this now. During positive pulse, what happens we can see first. During positive pulse, I want to check which diode is on and which diode is off. But I have taken this diode is a D1 for example, but I selected for example this diode is on. Just wait 1 minute. Yes, this is the diode D1 I have taken. This is the diode D2 I have taken here now. Identify which diode is on here, which diode is on here. You please identify. Which diode is on? D1 is forward bias or reverse bias. When the positive pulse is given, D1 is reverse bias. Positive is connected to the N-type material. This is off state only. This is a positive pulse is given to the P-type semiconductor. D2 is on. I say during the positive pulse, D1 is off. Why sir? This is a reverse bias. Positive is given to N-type. Then positive is given to P-type semiconductor here now. I can say D2 is on. This is on state only. If it is on, it must be replaced by short circuit, you know. The VIN is here connected with positive voltage. 4 volt, this voltage, maximum voltage, how much here? Maximum voltage, how much? During the positive pulse, we can take, is it given in the supply 10 sin omega t, 10 volts is the maximum voltage. 10K resistor we have here. This diode is a open, reverse bias, open. Open means this total branch we can remove. It is a open circuit. This D2 is a shorted here, and I can have one 4 voltage battery. I wish to find what is V out. This is the V maximum. V out is nothing but the V maximum. Polarity given plus minus. Directly we can write. In between these 2 points we have 4 voltage only. V max is nothing but the 4 volts. We can put directly. V max is nothing but the 4 volts. But A and C are not correct here now. Is a 4 voltage. 4 voltage in the B, 4 voltage in the D also we have. Without finding the V minimum, we can't get it now, because both are given 4 voltages only here now, V max. To find the V minimum during negative pulse, which diode is on, you identify. During negative pulse, negative means negative is given to negative. This diode is a forward bias. D1 is forward bias. Negative is connected to the P-type semiconductor. D2 is off. I can say D1 is on, diode D1 is on and D2 is off. And I can redraw this circuit. What way we can redraw this circuit? This voltage is given negative only now. Minus 10 I can put here now, maximum 10. Minus of 10 voltage. Minus 10. Here the resistance is nothing but the 10K resistor here given. This diode is a shorted because it is on state only now. When it is on state, we can replace by short circuit because it is a ideal diode only now. Is it correct or not? The diodes are ideal here, specified clearly, ideal diodes given in the problem. I can short circuit directly. The voltage is here given 4 volts and 10K resistor is connected this side. This is 10K resistor only now. We want to find voltage in between these two terminals. Between these two terminals, we need to find the voltage, that is V minimum. I want V minimum only. This voltage I want V minimum. How to get V minimum? This voltage 4 voltage, but voltage across 10K required. How we need to take the direction of the current in this particular loop? This is the loop we have. In this loop, current will be passing from positive to negative. This side it must flow current. This is the current. We should know initially this current. If the current is passing this side, polarity for the what now resistor I can put, this is a plus, this is a minus I have taken here. So when you want to find the V minimum, minus this one minus polarity, this is a plus, minus 4 voltage minus voltage across 10K, then I can get the V minimum. So without knowing the current, I cannot find this 10 resistor voltage across 10K. How to find this current? The current I is nothing but voltage by 10 minus 4. I go this side minus 10. I try to apply the KVL here. Just apply KVL. When I go this side minus 10. When I go this side plus 10I plus 10KI, 20KI, I can write directly. When I go this side plus 4, that equal to 0. Just I applied the KVL, Kirchhoff's voltage law I applied. Then I want to find what is I. 10 minus 4, 6 by, I can write 20K, I can get. 3 by 10, 0.3. 0.3 milliamperes of current is passing. Please note down this, 0.3 milliamperes of current is passing here now. But my aim is to find V minimum from here to here. You can go this side, top to bottom. I want V minimum. What is V minimum? When I go this side, minus 4 here. When I go down, minus of 10K into I. 10K into I, 0.3 milli, 10 power minus 3. And finally, V minimum is nothing but how much it comes? Minus 4, kilo and milli cancel, 10 into 0.3, 3 is possible, minus 3 is possible. Finally, its value is a minus 7 volts we are getting here now. Minus 7 volts possible V minimum. V minimum is 7 voltage. Can you say which option is correct here? Which option is correct in the problem? Which option is correct in this particular problem? I am getting V max 4 volts, V minimum minus 7 voltage. So option D is correct in this particular problem. Option D is correct in this particular problem. Please note down this. So these are the problems from the diodes I selected for practice in this session. Now I would like to give few number of questions from the DC analysis of the BJT and also AC analysis of the BJT. I wish to give few number of questions now. You can try these questions now. I hope you followed so far. Yes, I want to give the question now. This question solution is required. But I will give you time. You please try this question. I want to give you time now. But for this question, it is not required more time, but I think 2 minutes are maximum only. No, it doesn't require more, I think. Yes, I am giving the 2 minutes. Please try it. Yes, type up here. Anybody getting answer for this question? Nobody messaged. It's a GATE question. In the electrical paper given, GATE 2024. But how we can tackle this question? How to tackle this question? Please watch it. How the question is given here? Please watch it. Please note down the question he is asking. A BJT biasing circuit is shown in the figure, where VB equal to 0.7 voltage and beta equal to 100. The quotient point values of VCE and ICR respectively. Is asking to find the Q point. Q point means quotient point or operating point. In the operating point, we need to find VCE value, collector to emitter voltage required. Collector to emitter voltage. IC required. IC means current across this, RC is needed. These are all the parameters we need to calculate. How we can find this is more important. But here, what biasing circuit is given here, you check it. What biasing circuit is given? There are different types of the biasings, everybody know. One is a fixed biasing, one is a collector to base biasing and voltage divider biasing, like that. Certain types of the biasing circuits are there now. The given circuit is a voltage divider biasing. This we can call voltage divider biasing and also universal biasing. Universally we are using. If you are given any voltage divider biasing, you need to convert into the cell biasing circuit. Cell biasing circuit means base is connected with a single resistance with a base voltage and base resistance only. Voltage divider biasing circuit, you have to convert into the cell biasing circuit. How we can convert into the cell biasing circuit? From the cell biasing, we can get easily now. I can redraw this network in this way. I can redraw the network in this way. This is the transistor here given. RC is given 2 kilo ohms. This is 2 kilo ohms, 2K I am putting. Supply voltage VCC is given 12 voltage. 12 voltage given. Here R1 is given, here what now? This is the 50 kilo ohm is nothing but the R2. This is R2 value. R2 is given 50 kilo ohms, 50K. And here, I'll draw clearly. 50K given. And emitter is connected to RE 1K. RE is connected to the ground. Emitter resistance is given with 1K. Now what I wish to do, this R1 I want to bend out. Just I bended this R1 with a source. This R1 is connected to VCC. Along with this VCC, I can bend. If I bended this network, you will get in this form. This is with R1 100K and supply voltage 12 voltage, you know very well. So VCC 12 voltage, R1 is a 100K and R2 is a 50K and RC is a 2K and RE is a 1K. Yes, these are the values we are getting here now. But here you need to understand this, you have to simplify still more, because the same circuit first I have drawn, just redrawn this network. But my aim is to get the cell biasing circuit. Cell biasing circuits means this circuit we can draw like this. This is RC. RC is a 2K. This is a 12 volts. One base resistance. That base resistance is said to be Thevenin's resistance. Thevenin's equivalent circuit you have to get. This one. That means this is open circuit at first, which is open. Transistor is open. If the transistor is open, you find VTH and RTH for this network. Why we need to find VTH and RTH? To simplify these networks. I want to convert into the Thevenin's equivalent circuits. Thevenin's equivalent circuit is with what? One resistor with one voltage source alone. That voltage must be VTH, you know very well. Here the resistance is given RE 1K. Finally, this circuit we can call it as a cell biasing circuit. The modified form of the what now? This voltage divider biasing circuit is a cell biasing circuit. From this cell biasing circuit, we need to find what is VTH and RTH, very important. VTH means voltage across this R2. Voltage across R2 is nothing but the VTH only. According to, because the current will flow this side it won't flow because it is an open circuit I said now, as per Thevenin's. Supply voltage into R2 by R1 plus R2, 100 plus 50, 150. 53, 3 fours, 4 voltage I can get here now. I am getting VTH is nothing but the 4 voltage. I am getting VTH equal to 4 voltage only now. Please note on this. We are getting VTH 4 voltage. But when the view is made from this direction, wherever the voltage source is given, you short circuit and try to view the resistance. Some resistance this side, some resistance this side. These two are in parallel. RDH equal to, you know, formula. Yes, somebody asking here now. C is the correct option. Yes, I will check. C is the correct option, you say. Yes, C is not the correct option. C is not correct. It is incorrect only. Please check it once again. Srivatsava, please correct again. C is not correct. Check it. But VTH is the 4 voltage. I want to find what is RDH here now. RDH means these two are in parallel. 100K and 50K are in parallel. 100 into 50 by 100 plus 50, 150. 53, that means 33.33. 33.33 is mostly possible. 33.33 kilo ohms. Kilo ohms, that much resistance is possible. That much resistance is possible. But this current is nothing but because I want to find IC at first. IC is nothing but the beta into IB. If it is in saturation mode, if it is in active mode, IC equal to beta into IB only now. VC required. By using the IC, VC you can get now. I made an assumption it is in active mode only. After finding the VCE value, we can check, is it in the saturation or otherwise what? Is it in the active mode? We can check it all now. But this current is nothing but the base current IB. This current is IE. Emitter current equal to IB plus IC, everybody knows. IB plus IC. IC equal to beta into IB. If IB is taken common, 1 plus beta times of IB. IE equal to, we can write 1 plus beta times of IB. Directly can write. Sir, why you are converting in terms of the base current? Initial I wish to find the base current. By using the base current, I can find the IC. Just I want to apply the KVL in this particular path. Just I want to apply the KVL in this particular path. We know VTH. VTH is nothing but the 4 volts. When you go this side, some drop 1K into IB. From here to here, base to emitter voltage is given in the problem 0.7 voltage plus 0.7 plus drop across 1K into 1 plus beta into IB, 1 plus beta into IB. Beta is 100, 100 plus 1, 101 into IB value. Use calculator and please find what is base current. Without base current, I cannot get IC value. I cannot get IC without IB. The base current is mostly 0.024, 0.024, 0.024, 56 milliamperes, 56 milliamperes. Not required that many digits. 0.024 you round off 25 milliamperes accepted. That much current we are getting, that is in milliamperes only. That is in milliamperes only we are getting. But my aim is to find IC and VCE. IC is nothing but, I made an assumption the transistor is in active mode. This is my assumption initially. IC equal to beta into IB I have taken here now. The value of beta is given here 100. I can put as it is. The base current is nothing but 0.02456 milli only now. What is final answer? 1 to 2.456 milliamperes of current is passing. 2.456 milliamperes of current is passing. 0.256 for 0.456. But 2.456 means 2 decimal places I want to approximate. If you approximate it, 2.46 also allowed. 56 I have taken as a 6 only now, approximately. 2.46 only we are finding in the options only. That's why just I, rounded off to 2 decimal places only now. That's why 2.46 we are finding in the A and B also. C and D are nothing but 3.13, 3.13, not possible now. That's not correct now. So 1 A or B here correct now. After getting IC value, we need to find the VCE value. This voltage is required. I want this voltage VCE. To find this voltage, what you need to do? You must apply the KVL from top to bottom. Just you must apply the KVL, no other way. Only by this method you can find its value. Understand my point? No other way possible here. Understand here now. But I wish to find what is VCE. If I apply the KVL, 12 volts equal to, when you go this side, some drop 2K into IC here, 2K into IC 2.46 milli 10 power minus 3, 2.46 milli plus VCE here, plus VCE. Plus drop across this 1K into 1 plus beta, 100 plus 1, 101 here. Multiply by IB into IB. IB is nothing but 0.02456 into 10 power minus 3, you know very well. You can use the calculator. VCE required. What is VCE value? I am getting VCE value as 4.6 voltage here now. 4.6 voltage I am getting. Now you please tell me, By making an assumption of the transistor is in active mode, I did the work here now. I did the work making an assumption of the transistor is in active mode. Is it in the active mode or not here now? 100% it is in active mode only. Why it is in active mode? If VCE is greater than 0.7 voltage, 0.2 voltage, the VCE is greater than 0.2 voltage, we can say the transistor is in active mode only. It is in active mode only. It is in active mode only now. 100% our assumption is correct here now. Our assumption is correct. Finally, which option is correct? VCE 4.6 voltage and current IC equal to 2.46 milliamperes. Option A is correct here now. I can say option A is correct in this particular problem. Option A is correct for this question. Any student having any doubt regarding this question? This is somewhat lengthy one, Year 2024 in the electrical paper asked. From the beginning, I am informing to the students, your practice is more important. This is not for my practice, this is for your practice. When the problem is given, you must do on your own, and you need to get the solution, and you need to message whether it is correct or not to check it only now. But how well you are doing, you can understand because of this gate score booster session now. This is for improving your level only now. That is why you need to pay attention. You need to practice more now. Understand now. You should not wait for my results. Understand my point now. Your work is required more on your side. If you have any doubts regarding these problems, immediately you can ask your doubts. I am ready to clarify. Understand my point now. I am giving you a chance to ask the questions also regarding these questions now. This is the best platform to clarify your doubts also now. Some extent we can clarify. Understand now. The time is a minimum only here now. Yes, next one. The next problem I want to give. Yes, this is the next problem. I want to give 2 minutes for this. Yes, time up. Nobody is getting answer? Getting anybody answer? Can you message? Which option is right here? Which option is right in this particular problem? It's a good question, but around 2 times asked in the gate the same model question, I think, How the question was asked here? The circuit shown in the figure uses matched transistors with a thermal voltage Vt equal to 25 millivolts. Thermal equivalent of voltage given 25 millivolts. The base currents of the transistors are negligible. Base current of this and this neglected only now, because it is a less current. The value of resistance R, this value of R in kilo ohms, that is required to provide 1 microamp bias current for the differential amplifier block shown is dash. Give the answer up to 1 decimal place. That is the given problem. Can you say what is the name of this network? What is the name of the network? Anybody? Anybody knows what is the name of this network? This is nothing but the current mirror biasing circuits. But in the current mirror biasing circuits, 2 sort of the questions you can find, 2 types of the questions. Without this R, with R they will give. Without R, with R they will give. Without R means very simple, you know everybody. In this problem, with R is given here in the gate. With R is given in the problem. How we can tackle this? But thereby required resistance of R. Resistance of R is required. You know very well, current mirror biasing circuit is usually used where we are using. As a current source, we are going to use constant current is going to flow, this IC2, to maintain the constant current in the differential amplifier, where emitter side only now. Constant current, if you want to allow, this circuit is generally used, everybody knows. But anyhow, I want resistance R here now. How to get resistance R? I will explain, please watch. I want to explain here now, some explanation required. This voltage is nothing but the transistor T1 I have taken, for example, this. This I want to take it as a T2 value, transistor T2 I can put. Base current is neglected, base currents are negligible is given. This current is a IC2, you know very well, IC2, this current must be IC1. Collector current of the first transistor, collector current of the second transistor. I say the same current IE equal to IC2, IE2 equal to IC2 I can take. Why, sir? IE equal to IB plus IC, base current is neglected at the time IE equal to IC2 only. That is why this current is IC2 itself. Understand now, same IC2 possible. But anyway, student can give voltage across this transistor, voltage across this transistor, base to emitter voltage of this, base to emitter voltage of this, how much? My question. Any student can give? What is base to emitter voltage of this, base to emitter voltage of this, T1 and T2? Any student can respond? I want your answer. It's very important question. Base to emitter voltage of this I want. Any student can give? VBE1 and VBE2. Any student? At least to tell me otherwise, VBE1 and VBE2 are equal or unequal here. VBE1 and VBE2 are equal or unequal? My question. Base to emitter voltage of first transistor, base to emitter voltage of the second transistor are equal or unequal? That is my question. Anybody can respond? You must respond, then only the subject will come out. Nobody is responding? Yes, I cannot say this voltage and this voltage same. VBE1 and VBE2 not equal. The reason behind it is, suppose if I selected this node point, even you selected this path, even you selected this path, these two voltages must be same required. Both are in parallel. This voltage and this voltage must be same only. Because here VBE2 plus drop across R is equal to VBE1 only. Catching my point now? From here to here, this voltage is equal to this voltage plus drop across this, because this is totally parallel to this only now. I say this is VBE1, I say this is a positive, this is a minus here, this is a plus, this is a minus, this is a VBE2 I can take. VBE2. Just I applied the KVL in this path. If I applied no minus 12, it doesn't have any effect. Directly KVL. Minus 12 will not have any effect. Minus VBE1 I can take here, minus VBE1 here. Solution I can take minus VBE1 here I have taken, plus VBE2 plus R into IC2, R into IC2 equal to 0. These two voltages equal to this voltage only. No effect of this voltage if you apply the KVL. Here I can say IC is nothing but, what is IC? R value I want, sorry, R value I want here now. My aim is to find R. My aim is to find IC2 only here now, IC2 here now. I want R value. R is nothing but VBE1 minus VBE2 divided by IC2 I can write, by IC2. That is R value. But thereby required, what is VBE1 and VBE2? From the electronic devices and circuits, you know very well. Sorry, from electronic devices, from EDC, electronic devices and circuits, base to emitter voltage in the transistor is calculated by this formula generally. Base to emitter voltage is calculated by the formula thermal voltage into log of ln of natural log of IC by IS. This is the general formula in EDC, electronic devices and circuits you will use. VBE, thermal voltage, base to emitter voltage equal to thermal equivalent of voltage, natural log of IC by IS. IC by IS. But IC means we know collector current, VT is the thermal equivalent of voltage. What is IS? IS is the reverse saturation current. In some books they will write IS, some books they will write I0. I0 and IS same, reverse saturation current. Here I say the resistance R is calculated by the formula 1 by IC2 I have taken common. VBE1 is nothing but VT into thermal equivalent of voltage same, ln of VBE1 means IC1 by IS, reverse saturation current same. What about VBE2? VBE2 is nothing but minus of VT into ln of IC2 by IS I can write, by IS. By IS I can write. I can take VT in common. If taken VT thermal equivalent of voltage in common, VT by I will get IC2. Then I will log M minus log N. Log M by N I can write ln of natural log IC1 by IS divided by IC2 by IS I can write. IS cancel. Finally, the value of R is calculated by thermal equivalent of voltage by IC2 into ln of IC1 by IC2 I can write. The formula you need to memorize. I cannot memorize the formulas or you derive it. I cannot derive or you memorize it. Understand now? Options 2 only. No third option. I cannot memorize, I cannot derive or you need to leave the question only. No other option. Understand now? 100% you memorize. Don't derive, just memorize that formula. The resistance R is calculated by this formula only. But in the problem it is given clearly, thermal equivalent of voltage is given in the problem very directly. What is thermal equivalent of voltage? 25 millivolts. 25 milli. by IC2. IC2 is nothing but 1 microampere. 1 micro into ln of natural log. IC1, what is IC1 here? 1 milliampere. 1 milli divided by IC2. IC2 is nothing but 1 micro, 1 into 10 power minus 6. Use calculator, you will get answer. Use calculator. I am going very slow because every student must understand the concept. That's why I am doing very slow. What is its value? Anybody can give answer? Any student will give answer. You will get answer 172.7 kilo ohms. 7 kilo ohms possible because it is asking answer up to 1 decimal places only now. 172.7 kilo ohms possibles. That is answer. That is answer. I hope you followed. Yes, I want to give one more good question in your hand. You please try to tackle. By using the transistor, I wish to give this question also. Understand? The next problem. For this question, just 1 minute is just enough. It's not required more time. 1 minute is just enough to complete this question. Please try to tackle this question. I'll give the time. Initial work is required on your side. Yes, time up. Anybody has done this question? I'm not getting solution from any student. I think it's better to do. It's a very simple question asked in the gate once. It doesn't take more time. But may I know the way to tackle the question from your end, how we have to start? What is asking the problem first of all? The transistor used in the circuit shown below has a beta of 30. Beta value is directly given in the problem, 30. And ICBO is negligible. Collector to base current when emitter is open circuited is negligible. ICBO is nothing but the leakage current. It is also leakage in collector to base. What leakage current is flowing? The leakage current generally comes when the temperature is increasing, covalent bonds are broken between the collector and base, and multiple number of minority carriers are generating and can develop the current of ICBO. That current is neglected. It's a very, very small. That's why it is neglected ICBO. That's my point now. But in this problem, you watch VB is a 0.7 voltage. Base to emitter voltage is 0.7. VC is SAT 0.2 voltage. VC is SAT 0.2 voltage. And VZ is a 5 voltage, 1K resistor. That must given here now. But in this problem, directly VC SAT is given 0.2 voltage. We can assume the transistor is in saturation only. It is in saturation only now. Why? VC given there directly 0.2 voltage. When the transistor is in saturation, you will get VC, but when it is in saturation, directly you can take. When the transistor is in saturation mode, directly you can take VC is sat equal to 0.2 voltage, even given or not given. As VC is sat is given, we are assuming transistor is in sat only now. Sir, I will not accept, sir. If you don't accept, you assume it is in active mode, you find out the VCEV. That VCE value, if you are getting less than 0.2 voltage, you can say it is in saturation mode only now. But anyhow, in the problem, it is directly given VC is sat 0.2 volt. It is in saturation only now. If it is in saturation, we don't need to worry. This network will not be useful now. Very easily you can get. What is asking? If the forward voltage drop of the diode is a 0.7 voltage, VBE 0.7 voltage, then current to the collector will be, is asking current to the collector. Is asking current to the collector. This collector current is required. How to get that IC value? How to get that IC value? I am asking. But it is, if it is in saturation, directly KVL you can apply this side. Directly you can apply KVL to find the value. Directly you can apply the KVL in this path. As VC is sat is given 0.2 voltage, I thought it is in saturation 1. Not accepted, you find whether it is in active mode or saturation. You know, in the classroom I explained how to find active or cutoff or saturation. But when I apply the KVL, 0 voltage equal to, I can take 0 voltage equal to, I can note down here. When I go this side, 2.2K into IC, 2.2K into IC. Collector to emitter, when it is in saturation, given 0.2 voltage plus 0.2 voltage. When you go down, minus 12. That's given. But I want IC here. IC value required. IC equal to, I can take IC equal to 12 minus 0.2, 11.8 divided by 2.2K. And you find its value. Directly you will get IC value. I say its value is 5.36 milliamperes. 5.36 milliamperes it comes. That much current is possible. IC equal to 5.36 milliamperes means option D is correct here now. Which option is correct? Option D is correct here now. This option is correct only now. 5.36 milliamperes of current is possible. Very simple question. Easily you can do. 5.36 milliamperes. Understand now, such a way we can tackle this question now. It doesn't take more time. Understand now. Directly KVL. If it is given, saturation directly. And I want to give one more question. You please try this. This is the next transistor problem. But I want to give 3 minutes for this question. I want to give 3 minutes. It takes some time, that's why. Sometimes you can expect somewhat lengthy questions in the gate. In 3 minutes, please try to complete this question. Yes, time up. But I gave you more time to tackle this question. The reason behind it is, the problem is somewhat lengthy question, this one. It's a great question, but it needs some time. Directly you will not get answer here now. Understand now? In 1 or 2 steps you cannot get answer now. If you have your knowledge on network analysis, you can tackle this question. Otherwise, not possible. What is given in the problem? In the circuit shown in the figure, the bipolar junction transistor has a current gain beta equal to 100. Directly given beta value 100. There is a current gain is given. The base emitter voltage drop is constant. It is a constant means how much? VBE 0.7 voltage here given. The value of the Thevenin's equivalent resistance RTH in ohms as shown in the figure is dash is given. Is asking to find the RDH value when the view is made from A and B. When the view is made from here, is asking to find RDH. The network analysis, you know one formula, but the transistor circuit is given with a concept of network analysis here now. I can say here RTH is nothing but Thevenin's resistance is nothing but VTH by Thevenin's voltage by short circuit current. By using this formula, generally calculated RDH value. There are different formulas, but I say this is a easy, this you can apply easily in these particular circuits. You find what is Thevenin's voltage, what is short circuit current. By using those 2 parameters, we can find the RDH value. How to find VTH? AB must be open circuited initially. I can redraw this network in this way. There is a transistor, is a 10K resistor here given, 10K. This side 10 ohm resistor is connected here. This is 10 ohm resistor and 15 volts battery here. And this is connected with a 10.7 volts. This is connected with 10.7 volts. And 1K resistor is connected in between these 2 terminals. This is 1K. This is 1K. And the voltage across this AB required. This is the open circuit voltage. Thevenin's voltage must be open circuit voltage. VTH or VOC, open circuit voltage allowed. So that voltage required to find the RDH. But this point A, you know, this point B. If you apply the KVL in this path, you will get the VTH. VTH equal to current passing through 1K into 1K resistor. But what current is passing across 1K? Emitter current. This is emitter current. The emitter current equal to, you know very well, 1 plus beta times of IB allowed. Same IE flows in this direction. Same IE. So 1K into IE is nothing but 1K into IE. I can write clearly. I say 1K into IE. I am applying the KVL in this part. 1K into IE is nothing but the VTH. How to get this IE? Just apply the KVL in this part. To find the IE, IB is required, base current. Even this current also same base current, you know very well. This is also base current. Apply the KVL and find the base current. Once you are getting the base current, you will get the IE value, IE into 1K VTH1. If I apply the KVL 10.7 volts, that equal to 10K into IB plus base to emitter voltage is given 0.7 voltage here now, 0.7 voltage here I can take, plus 1K into I 1 plus beta. Beta is 100, 101 into IB I can write. My aim is to find IB here now. What IB is possible? 10.7 minus 0.7, I will get the 10. Divide, this is 10K plus 101, 1K. How much it comes around? The value will be around IB I want now. The 10 by what it comes 101 and 111 milliamperes possible. 10 by 10 plus 101, 111 milli, K means milliamperes. 10 by 111 milliamperes possible. By using this IB, I can find VTH here now. Thevenin's voltage is nothing but 1K into IE. 1K into IE is nothing but IE means 1 plus beta. Beta is nothing but the 100 into IB. IB is nothing but 10 by 111 milli. And finally, I will get VTH value. The VTH value is 1010 by 1010 by 111. 111 volts possible. That much voltage is possible, volts. That is VTH value. Please note down this first. So, I am getting the VTH value, but I want short circuit current ISC. ISC means A and B must be shorted. If A and B is shorted, can you find any current across this 1 kilo ohm? Can you find any current across 1 kilo ohm? No current, because it is short circuited now. If it is short circuited, no current will flow. At the time, I can remove this 1K. The rest of circuit I can draw. I say that to find RDH, sorry, to find ISC, I am drawing the circuits. There is a resistor and there is a battery. This voltage is given here 10.7 volts. 10.7 volts and resistance of value 10K is given here. This is 10K. And directly this emitter is shorted here now. I want to remove what resistor? The short circuit current. And this side circuit is unnecessary, this circuit. This will not help you understand. But anyhow, for your understanding purpose, I am drawing. 10 ohms and 15 volts, 10 ohms and 15 volts. This is connected 10 ohms and also 15 volts here connected. Anyhow, that will not be useful, 15 volts here. Yes, that's given. But this this voltage is a 0.7, no doubt. ISC is nothing but the emitter current only, same emitter current. This emitter current and emitter current you are getting in the before case. In finding the VTH, you got IE. That IE and this IE not same. Short circuit current only, no resistor. But how to find this IE here now? IE is nothing but 1 plus beta times of IB, you know very well. You find IB, you will get IE. I can apply the KVL in this path again. If I apply the KVL in this path, I will get 10.7, that is equal to drop across. This current is nothing but the base current, you know very well. 10K into IB 10K into IB plus drop across this 0.7 plus no more drop, that side. I can close that now. 0.7. Then you find what is IB here. IB is nothing but 10.7, 10 by 10K. 10 by 10K is nothing but 1 milliampere of current is possible. IB is nothing but 1 milliampere is possible. IB equal to 1 milliamperes. By using this IB, I can find ISC. 1 plus beta. Beta equal to how much here? Beta is 100. 101 into 101 into IB 1 milli. Finally, 101 milliamperes only. 101 milliamperes only. Am I correct? But I need to find RDH now. I want RDH. You know the formula VTH by ISC. What is VTH? We are getting already. Yes, VTH we are getting 1010 divided by 1010 divided by 311. Sorry, 311 here. Into ISC. ISC is nothing but 101 milli. 10 power minus 3. Use calculator, you will get answer. If you are using the calculator, its value is around 90.09. 90.09 ohms, you will get answer. This is the solution for this question. Please note down this. I hope you follow. I hope you followed this. But I want to give you one more question here now. By using small signal amplifier, I wish to do few more questions now. Just 2 questions I want to do. Secretaries, please note down this question. Yes, this is the next question. This is the next problem. Please tackle this question. But I want to give just 1 minute is just enough to tackle this question. 1 minute is just enough. Please write. Yes, time up. I am not getting answer from any student. Nobody messages. Nobody messages. Yes, what is asking in this problem? Please check it. Please check what is asking the problem. A small signal source Vi of t equal to A cos 20t plus B sin 10 power 6t is applied to a transistor. The input voltage is given with 2 signals only. A cos 20t plus B sin 10 power 6t is given here now. 60 is given, is applied to a transistor as shown below. The transistor has beta equal to 150 and HIE, this is HIE, stand. HIE equal to 3 kilo ohms. Which expression best approximates V0 of t? But in this problem, required what is V0 of t? 4 options are given. Which option is right is asking. Anyhow, we are getting an idea. Here the input voltage is given small signal itself. A small signal source is given. So, small signal amplifier, this one. By using this small signal analysis, we need to tackle this question. In the small signal amplifier, there are different techniques to tackle the questions only. 4 methods are there now. One is said to be H parameter model, second one is said to be approximate H model, third one is nothing but the RE model, fourth one is nothing but the R pi model. Out of these 4 models, which model we can apply, you need to identify from the given problem. Once if you are getting an idea, directly you can apply that method. It does not take time if you identify. But generally H parameter model you are going to apply exact model, that one. If all H parameters are given in the problem, we are not given HI and HFE, HOE, but like that all H parameters not given, we can't apply H parameter model. Second one is nothing but the approximate H model. Approximate H model is applicable when you are given 2 H parameters. What are the 2 H parameters? HFE and also HIE. HIE given 3 kilo ohms, 1 H parameter. One more HFE. But sir, where is HFE? HFE and beta are same. HFE means current gain only. Current gain. The current gain is nothing but the beta also. Beta is said to be HFE, that is a 150 given. Anyhow, in this problem it is given 2 H parameters, HIE and HFE. But when you can apply RE or R pi, any model you can apply, only 1 H parameter, HFE will be given. HFE means only beta given, means you can apply RE or R pi model. Anyhow, in this problem it is given 2 H parameters. I must apply approximate H model to find output voltage. In the approximate analysis, I derived one formula in the classroom also, everybody knows very well, those who attended my class. But a V0 is calculated by, I will give applying approximate H model. Approximate H model. H model. Apply approximate H model. But using the approximate analysis, I derived in the classroom also. That formula directly you can apply here now, understand now. Because in the gate it is required formula application. We cannot derive this now, that much time we don't have. But a V0 is required, V0 of t required. V0 equal to, we know very well, minus HFE into RC formula, you know. HFE into RC divided by HIE. This is the formula in approximate H parameter model. In approximate H parameter model. These are not V0, voltage gain, sorry. V0 by VI. VI of t. This is called as a gain, voltage gain formula. By using the approximate analysis, I derived voltage gain V0 of t by Vi of t, that much only. But in the problem is asking V0 of t. V0 of t means you have to multiply by Vi of t. Minus HFE into RC by HIE multiplied by Vi of t. Vi of t. But in this problem you need to watch. What is Vi of t? Vi of t, A cos 20t given and also B sin 10 power 60 is given. 2 signals are given. But you need to watch the frequency of each signal here now. The omega equal to 20 is given. Omega 1 is given 20, a cos omega t, omega 1 t, omega 1 equal to 2 pi f, and you find out the frequency. Less than 20 hertz you are going to get now. Less than 20 hertz, whenever you are getting, it is a low frequency one, Less than 20 hertz, whenever you are giving input side, is a very low frequency. At this low frequency, the reactance of the capacitor is very high. At the time, it is going to block that signal. We signal low frequency waveforms are blocked by the what now? This capacitor, input side capacitor one, That means this signal will be stopped. Why? Less than 20 hertz only you are getting. But if you have taken this second one, 10 power 6 omega 2 equal to 10 power 6, that equal to 2 pi f, f you find. More than 20 hertz you are going to get now. More than 20 hertz means high frequency, more than 20 hertz, high frequency. At this frequency, the capacitance of the capacitor will have the reactance of very, very low. At the time, it will allow the signal one, Now, the point what you have to understand, this signal will not be accepted by the capacitor. The reason is high capacitor reactance. This will not be accepted. B sine 10 power 6, this signal will be accepted because it at high frequency capacitor can act as a short circuit, it will allow, Then finally, I will get value. And the point what I wish to say, V naught of t is nothing but minus HFE. HFE is nothing but beta value I said. HFE and beta value same, 150 into RC value, this is RC 3 kilo ohms, 3 into 10 power 3 divided by HIE. HIE is nothing but the 3 kilo ohms. HIE 3 kilo ohms, 3 into 10 power 3. VI of t. VI of t means don't take A cos 20t plus B sin 10, but this is stopped by the capacitor. That will be taken B sin, how much? 10 power 6t. And finally, 3 into 10 power 3, 3 into 10 power 3 cancel here now. I will get V0 of t is nothing but V0 of t is nothing but minus 150 sine minus 150 B sine, I say. 150 B sine 10 power 60 is possible. That much voltage is possible here. So, which option is correct here? Option D is correct. Minus 150 B sine 10 power 60. So, option D is correct in this particular problem. I say option D is correct in this problem. This option is correct. Option D. This option is correct. I hope you followed. And I wish to give one more question in your hand. Please try this. Please try this question without my help. I'll give one more good question. By using this small signal amplifier, I wish to give one more question. By using the what? Small signal, one problem I have done. There I applied approximate H parameter. Next one you try, I will give. This is the next question. You please try this question without my help. I will give 2 minutes. Please try it. Yes, I am up here. Yes, here solution required for this question. What is asking in the problem? Please check it once. For the DC analysis of the common emitter amplifier, circuit is a common emitter amplifier. Neglect base current, asking to neglect the base current which is passing through the transistor, base current, and assume that the emitter and collector currents are equal. Assume that emitter and collector currents are equal. That means the IC and IE are same, he says. Given that VT equal to 25 millivolts, VT is nothing but thermal equivalent of voltage, VB base to emitter voltage 0.7 volts, and the BJT output resistance R0 is practically infinite. Mostly R0 is given, output resistance of the transistor is given infinite. Under this condition, the midband voltage gain magnitude, midband voltage gain means voltage gain only required. AV equal to modulus of V0 by VI, V0 by V1. VV means what now? No, what now? V0 is in volts, V1 is in volts, volts cancel means without units you will get now voltage gain. Anyhow, in the problem it is required voltage gain V0 by V1 with modulus required here now. How to get? But in this problem, one parameter is given. Which parameter is given in the problem here? Beta is given or not given? No. Thermal equivalent of voltage given 25 millivoltage only now. VBE 0.7 voltage, no problem. Anyhow, base current is neglected is given here now. When the base current is neglected, beta value you will not give. If the beta is a very large, we are going to neglect the base current generally, we know. Here I am applying the RE model. If the RE model is applied in the small signal amplifier, it becomes very simple only. RE or RPi, any one of the method you can apply in the gates. The choice is yours. But I feel RE is a very easy. I am applying. If you feel RPi is a easy, you can apply also instead now. But in the classroom, I explained RE model and RPi. I did number of problems also. Okay. Anyhow, here I will apply RE model. But how to apply this RE model here? According to the RE model, voltage gain is calculated by voltage gain. How to get? The network you watch, emitter resistance and CE are connected in parallel below emitter. In the 4 cases of questions you will find mostly in the small signal amplifier. RE parallel to CE, one model. No RE, no CE, directly shorted, type number 2. Type number 3, no CE, only RE will be existing, only RE will be existing. Third case. Fourth case, RE is existing, no RC, RC is shorted here now. Across RE, output is taken, emitter follower circuit, only 4 cases. By using these 4 cases only, you will do any problem. This is case 1, RE parallel to CE, emitter side, RE parallel to CE, if you are finding in the problem, voltage gain is calculated by minus RC dash divided by small re, direct formula I can apply. RE parallel to CE if it is corrected, below emitter, RE parallel to CE. RC dash means RC and RL are parallel here now. If you are drawing the small signal equivalent circuit, AC equivalent circuit, if you plotted RC and RL, it comes parallel. That is why you can take directly here now. RC dash is nothing but RC parallel to RL only. That means RC into RL by RC plus RL you will apply. RC plus RL to get RC dash. RC is nothing but the 2K and RL is given as a 8K. So 2K plus 8K, 10K I can get. 8 plus 2, 10, 10 cancel now, 1K it comes. 1 kilo ohm you will get now. RC dash is 1 kilo ohm. Please note down this. Sorry, 2 into 8 by is made mistake I think now. Here made mistake I think now. I made mistake I think. RC into RC is nothing but the 2K, 16 it comes, 2C, I am adding 2K into 8K by RC plus RL, 8 plus 2, 10. There is a 8 to 16, 16 by 10, K cancel, K it's possible, 1.6 kilo ohms possible now. 1.6 kilo ohms possible, no, that much possible, 1.6 kilo ohms. But how to find this RE value? Emitter resistance is required. But already given in the classroom I derived that also, how it comes RE explained. RE equal to, generally they will find thermal equivalent of voltage divided by emitter current. This formula is generally used. Emitter resistance equal to thermal voltage by IE. Thermal equivalent of voltage given 25 millivolts. IE is required under DC analysis, that is very, very important. IE value under DC analysis only required, under DC analysis. Under DC analysis, we need to redraw this network. Under DC analysis, wherever capacitor is given, that must be open circuited under DC analysis. Wherever AC voltage source is given, that must be shorted only now. Finally, the equivalent circuit I can get in this way. Under DC analysis, there is a transistor, 2K resistor is existing here, 2 kilo ohms. Supply voltage 12 voltage here given, and emitter resistance 2K here given. This is 2K. This is connected to the ground. Capacitor is open circuited under DC analysis. Under DC analysis, capacitor is open circuited. This capacitor is open circuited. This I can remove. R1 and R2 existing, 73K here. This is 73K. This is 73 kilo ohms. This is one more resistance. That is nothing but 47 kilo ohms. 47 kilo ohms possibles. But in this network, what now? This is voltage divider biasing now. In the voltage divider biasing, generally what now you have to convert into the cell biasing circuit. I explained today, I did one problem also. If you are converting to the cell biasing circuit, RDH must be connected in series to the VTH only. But I am not going to find RDH here now. Sir, why sir? Why don't you find RDH? Means very simple. Current through the RTH is nothing but the base current it passes now. RTH is connected directly to the base of the transistor. The base current is here given in the problem, directly given. What is given? Base current, neglect the base current is given here now. Neglect the base current. When the base current is neglected, voltage drop across the Thevenin's resistance will be neglected only. Current is 0 means voltage drop across RTH 0 only. So we need to calculate only VTH. VTH is nothing but voltage across this 47K. This is the VTH value. I want this value. Voltage across 27K. This current is 0. Because of 12 voltage, same current passes across 73K and 47K. And I can find VTH is nothing but base voltage or VTH, base or VTH. 12 into, according to voltage division formula, 12 into 47K divided by 73K plus 47K, again write. You find what is VTH. The value of VTH is 4.7 voltage possible. 4.7 voltage. 4.7 voltage possible. 4.7 voltage is possible here now. Followed? VTH we are getting now. After getting VTH, directly you apply KVL in this part. This current is nothing but the emitter current. Directly you can get IE if you apply it KVL. VTH equal to VDH is nothing but the 4.7. That equal to VBE is given 0.7 volts, 0.7 voltage, drop across 2K, 2K into IE. Use calculator, you will get IE. Use calculator, you will get IE value. The value of IE is 4.7 minus 0.74, 4 by 2k. 4 by 2k means 2 milliamperes of current is possible. That much current you will get. 2 milliamperes of current is possible in this problem. Now we can get what is AV minus RC dash by RE. I can do AV is nothing but minus RC dash by RE, I said. What is RC dash? RC dash 1.6K. 1.6K. RE is nothing but RE we are getting. Sorry, by using RE we need to find RE we have to find, I think. Here one side we can find what is RE also. RE equal to what I said, thermal equivalent of voltage by IE only. But a VT value given in the problem 25 millivolts, this is 25. This is 25 milli. You are getting IE value already. IE equal to how much here? IE is a 2 milliamperes. IE is a 2 milliamperes. And finally, the value of RE is 2 ones, 2 twos, 2 fives, 12.5 ohms possible. RE equal to 12.5 ohms possible. 12.5 ohms. And I can get RE, here RC dash by RE 12.5. Use calculator, you will get voltage gain. The voltage gain here is minus 1.6 by 12.5 minus 128 it comes, minus 128. That is the voltage gain possible. Please note down this. That much voltage gain is possible. That is the voltage gain is possible. Please note down this. But I wish to give few questions by using feedback networks. Please complete. It doesn't take more time. Just 1 minute. In 1 minute, you can complete this question. Yes, time up. Yes, the question from the feedback amplifiers. Anybody can do this question without my help? Any chance? Nobody gave the solution for this question. It is a very simple question. A voltage amplifier has a open loop gain of 100 is given. If 10% negative feedback were introduced in the amplifier, then 11% change in open loop gain would cause 4 options are given. Which option is correct is asking here now. How we can do this question? We can do like this. The open loop gain is 100. That is to be taken as a value. A is to be taken as a open loop gain. If 10% negative feedback were introduced in the amplifier, that's a beta value. Beta given 10%, 10 by 100. That must be beta value lies in between 0 and 1 always. is a reverse saturation gain, reverse transmission factor is denoted by symbol beta. Beta must be within the range of 0 to 1, 10%. That's why here the beta is given here 10%. 10% means 0.1 possible here now. Then 11% change in open loop gain. 11% change in open loop gain means open loop gain change dA by A into 100 is given. A means relative change of open loop gain is given. Relative change of open loop gain dA by A into 100 is given 11. dA by A means 11% possible finally, understand. And but what is asking now? The percentage change in the closed loop gain is required from the given problem. Asking all are in closed loop gain, change in the closed loop gain only now. Change in the closed loop gain is nothing but DAF by feedback gain, DAF by AF into 100. That equal to how much is asking the problem. This type questions asking in the gates. DAF by AF into 100 is a change in the closed loop gain. But a formula you know very well. In the feedback amplifiers, there is a formula. This is equal to 1 by 1 plus A beta into dA by A into 100 I gave it. dA by A into 100 is given. By using this formula, you can find change in the closed loop gain. We can get directly DAF by AF into 100 is nothing but 1 by 1 plus A beta. A is given 100 here and beta is given as a 0.1. 0.1 dA by A into 100 is given 11. The mostly this value will be, you will get 11, you will get examined. You will get as say, let me check. This is a 1% it comes now, mostly this now. This is a 1 possible, 100 is a 1 is possible here now, this is a 1. So DAF by AF means 1% only possible, 1% only possible. So 1 means this is a 1%, DAF by AF means 1 by 100, that is a 1%. There's a option A is correct only, I can say. Which option is correct? Option A is correct in this problem. Option A is correct in this particular problem. That is the solution for this question. Option A is correct. 1% change only now in closed loop gain is possible. That is the solution. But I wish to give you one more problem. Please try to note down here now. This is one more problem here now. Sorry, just wait. Sorry. Yes, this problem solution required. Anybody can complete this question without my help? I will not give you any time also. It's a very simple question, anybody can tackle. An amplifier has a gain of 1000 plus or minus 100 is given. This 1000 is nothing but A value. This is a 1000, this is a. Amplifier has a gain. Amplifier can have a open loop gain only, that one. That means say A value given in the problem 1000 and change in the A, the tolerance is given 10. The tolerance means change of A. Change of A is denoted by symbol dA. dA is given 10. Positive value you can take it now. Negative feedback is provided. Gain variation within 0.1% given here now. And beta value is given in the problem. How much given beta value? Beta value asking DAF by AF is given in the problem. DAF by AF. DAF by AF is given how much here? Into 100 is given. into 100 is given 0.1 percentage. 0.1 percentage is given. 0.1 is given here now. DAF by AF into 1, 0.1, and is asking to find the beta value. Beta you can get directly by using this formula. What formula? DAF by AF, it is same formula only, into 100 equal to 1 by 1 plus A beta into dA by A. You can use directly. Every value we know directly. Every value we know directly. If you are substituting every value, mostly beta value, you will get 9 by 1000. 9 by 1000 is possible. But I think I no need to do this question. Beta value 9 by 1000. Option, substitute all the values you know, every value given. So option D is correct in this particular problem. Understand my point now? And I want to give you last problem, one more question. One more question I will give. That problem is this. Yes, you tackle this question. What is given in the problem? An amplifier has open loop gain of 100. Open loop gain is given. And its lower and upper cutoff frequencies of 100 Hz and 100 kHz respectively. A feedback network with a feedback factor of 0.99 is connected to the amplifier. The new lower and upper cutoff frequencies at dash and dash given. What is given the problem here now? The open loop gain is given 100. I can take that value is nothing but A. A is given 100 directly in the problem. This model question is also asking sometimes in the gate. And the lower and upper cutoff frequency is given. FL is given here 100 Hz. And FH high cutoff frequency is given as F suffix H. F suffix H is given 100 kilohertz. 100 kilohertz is given. A feedback factor beta is given 0.99 here given. 0.99 is given to the amplifier. The new lower and upper cutoff frequencies required. FLF required low cutoff frequency after feedback. High cutoff frequency after feedback is required. These two cutoff frequencies are required. You know the general formula. After applying the negative feedback, gain will be reducing. When the gain is reducing, low cutoff bandwidth is going to increase. When the bandwidth is increased, low cutoff frequency will be decreased and high cutoff frequency will be increased. So we can write FLF. Low cutoff frequency decreases means FL is decreased by a scale factor of 1 plus A beta. Directly you can write. Decrease means 1 plus A beta. Increase means you can multiply 1 plus A beta. And I can write here now FL is nothing but 1000 here, 100 here. 1 plus A is 100 here. Beta is 0.99. You calculate what is FLF. The value of FLF is 1 Hz is possible. 1 Hz is possible. You will get 1 Hz. That is FLF. What about FHF? High cutoff frequency required after feedback. Just now I said because of the negative feedback, gain is decreased, low cutoff frequency decreases and high cutoff frequency increases. If it is increased, you have to multiply by 1 plus A beta. I say 1 plus A beta into, I can write FH, that is the high cutoff frequency. 1 plus A is 100 here and beta is 0.99 and FH is given here 100 kilohertz. 100 kilo. Use calculator, you will get FHF directly. That value will be 10 megahertz possible. 10 megahertz is possible. That is FHF is possible. I hope you follow. Note down this. Please note down this. But I hope you followed this problem. Yes. The students who wants to take coaching in the IMS Gate Academy, they must know what IMS Gate Academy provides to the students. The futures of the program futures you must understand. 800 plus hours of the live classes with a live interaction possible. And theory book, exercise book, there is a 4,000 plus questions it contains. The exercise books you can find level 1, level 2 and level 3 questions now. But all the level questions, number of problems are there now. So more than 4,000 questions are there now. The theory book can give explanation for each and every point only now. And also you can solve number of problems from the exercise books now. 34 plus years gate question bank with video solutions you will find. The GQB book, this is the GQB means gate question banks only now. Here solved 34 plus years of the what now? Questions were solved. But they are given video solutions also. For certain questions it is given 2 or 3 solutions also. Easily you can understand. Key points also specified in this particular book only now. 12 personalized one-to-one mentorship sessions also possible. That means to motivate the students and also to give the what now, to give the methods to prepare for the what now, this exam, everything will be given in the personalized one-to-one mentorship only now. 130 plus online tests with video solutions of the mock test and many more possible. If any students is willing to take admissions, they can make a call to this numbers only now. Understand now. The next ones. But if the students can join in our Telegram channel. If you are joining in this Telegram channel, schedules for the free YouTube lectures, you will get lecture PDFs are available, important dates and related to the seminars and webinars will be given, expert sessions on the important topics are possible. If you want to join, link is given in the description only now. Understand now. This is the Telegram channel now. Next one. Yes. But anybody wants to take test series plus, that also you can join. Here given what now limited period offer also given here now, get 20% of test series plus only now. But in this test series plus 130 plus online tests, 33 years of the GATE PYQ books, 33 years of the what now GATE PYQ books, maths and general aptitude, the technical subjects, doubt solving also down. In the IMS Gate Academy, a doubt solving what now portal is there now. While doing the problems, if any student is getting any doubt, immediately they can post. But each and every one of the faculty is ready to solve their questions as fast as possible. Not as fast, not 24 hours maximum they are receiving the solutions only now. But if it is delayed 1 or 2 days, means if they have any classes at the time delayed, it won't be delayed mostly now. In 24 hours they are going to receive mostly what now? Solution for the doubts only. Online revision and score booster, post-gate guidance and PSUs and all this possible now. Understand now. But I hope you followed so far. I think you solved number of problems along with me and you are satisfied with the subjects I explained. Understand now. Thank you.